Good evening, dear students. Yesterday, we've been discussing in last class about the concept of Gauss law and how to calculate the flux. And by calculating the flux, how to calculate the electric field, like that. These are the things we are already discussed. Today, let us apply our knowledge for different situations. Right. I think you are all could see it. So the basic flux calculation is the number of electric field lines crossing the area. So if this is the area, see this area is towards this direction. This area is towards this direction. So this, if the small area we have chosen here is having the value, the area is ds, small area, s is the symbol for area, small area we have taken, so ds symbol I have taken. Here through this area, electric field line is going straightly like this. This is the electric field line direction, so vector quantity. That means what, here somewhere one positive charge is there. That's why electric field line is going away. But this small area, this direction of the area is like this. So this area is in this direction. That's why we have to take the area in this direction. So this is also a vector. So we call it as a aerial vector. That is the concept here. If the same electric field line is going like this because of the same positive charge, if area is like this, see this area is facing in this direction. See, in this direction. See, this is the normal unit vector, normal to this one. So in this direction only, we have to take the this small aerial vector. Why? Because our definition says electric field, number of electric field lines passing through this area. See, if I draw like this is orienting upside. So all these lines won't go. See here, they are not spreading uniformly. So the area is in different orientation and electric field in different orientation. Here see, all electric field lines will pass through total area. Here they cannot pass through. That's why here angle theta is there. The direction of this area, the surface is in this direction. Surface direction is this. So area is also we have to take in this direction. In this direction we have to take. That's why here the general formula to calculate the flux is equal to the dot product of electric field and this aerial vector. So you know the dot product definition, E ds cos theta. Theta is the angle between the electric field and the direction of orientation of the surface, what we are which we are selecting. See here, the surface area is the surface is facing in this direction, and the electric field also going in the same direction. So angle between ds and E is equal to 0. That's why in this case the phi value is maximum. So maximum phi value formula is EDS only. Why? Because cos 0 degrees is equal to 1. But here, see, the ds is in this direction, the surface is oriented in this direction, electric field is going in this direction. Our formula is EDS cos theta. The angle between E bar and ds bar is equal to some theta. If we say it is 90 degrees, then the phi is equal to minimum. Why? Because cos 90 is equal to 0. That minimum value is equal to 0. This is how we have to apply while the concepts we are calculating the flux. See, our gauss tells a shortcut way. If a positive charge is there, around this positive charge, electric field is spreaded. So total flux we have to calculate. Just what he says, if you want to calculate flux, we should not leave this charge just like this. You have to imagine it is inside some imaginary surface. So slow, I drawn a circle. That means in 3 dimensions, it's a sphere, right? The sphere radius is r. So this is a small surface. So this surface is in this direction, and the electric field is also going in this direction. This is ds direction. Like this, so many areas we can imagine. So total flux around this charge, phi total, is equal to whatever the charge inside by the, see, if it is the electric line is coming out, it is has to travel all the way from here to here. If air is there, air permittivity we have to take. If something is there, some material is there, that permittivity we have to take. So this is what the gauss says. This is what we calculate the phi. This is the formula for phi calculation, flux calculation. This is the shortcut formula the gauss has given. So we equated both. So total flux is equal to total we have to take. So total surface, so surface integral. Here only we have taken one small surface, one electric field only. But here in this we are taking total surface. So total surface area. So surface integral E bar dot ds bar. This is the formula for total phi calculation, right? But total phi calculation according to gas, this is charge enclosed in an imaginary surface divided by the permittivity. This is actually the Gauss law. So let us apply for different cases, right? I think you are following. First case, yesterday also I discussed, once again we go with it. See, if we consider a cube, so this is a cube we are having. So exactly at the center, if positive charge is there, so a cube is having 6 surfaces. So from all surfaces, electric field lines will go away. Why? Because positive charge, so electric field lines will go like this. You all know this one, right? That's why it is there inside the cube. So in all directions, electric field will go. So total flux, how to calculate? Already given by the Gauss. So this is the imaginary block. We have a cube, we have imagined, and inside at the center exactly charge is there. So total flux coming out of this cube, phi is given by, this is total given by Gauss law. Charge inside the cube by the, see, this cube we have imagined. So only air is there, no material. So permittivity of that free space we have taken. If, see, in the exams they will ask, each surface what is the flux? See, 6 surfaces are there. Each surface means one surface. So per surface. For 6 surfaces, phi value is q by epsilon naught. For one surface, so for one surface, phi is equal to only this surface, okay, of, if not only this surface, of, if not that surface, so one surface. So we are taking one surface among 6. So this is the flux from each surface, q by 6 epsilon naught. If 2 surfaces we take, so the phi in 2 surfaces among 6, because total 6 surfaces are there. So q by epsilon naught, like this we can, so 2, 3, so q by 3 epsilon naught, like this. So 3 surfaces, 3 by 6, 4 surfaces, 4 by 6, like this each surface we can calculate. And also see, If we all know that if we consider a cube is having 6 surfaces and 8 edges it is having. Corners, I may say, sorry, corners. So 8 corners are there. So how much flux will come from each of the corner? So 8 corners are there. So flux is equal to from each corner. So total 8 corners, 1 corner we are taking. So 1 corner among 8. So Q by epsilon naught. Total flux is Q by epsilon naught only. But one corner. So if 2 corners, 2 by 8, 3 corners, 3 by 8, 4 corners, 4 by 8, like this. And how many edges are there? 12 edges are there. From each edge, see, each edge we are calculating. From each edge. So what is the flux coming out from this cube, each edge of the cube? 1 among 12. 1 edge we are taking out of 12. So Q by epsilon. So if 2 edges we take 2 by 12, 3 edges we take 3 by 12, 4 edges 4 by 12. Like that we have to calculate the flux linked with a cube when the charge is exactly at the center. If charge in a problem, if they say the charge is at one of the surfaces, at the center of the surface. See, this is a cube. The charge is at this center of the surface, only this surface. See, if we imagine a charge here, it is outside. See, inside cube surfaces are there, but outside no surface are there. So our Gauss says that charge must be exactly inside the, it should not be left out. So how to do? I have to imagine another another. Sorry. Now charge went inside. I got this much big one, right? Now the total charge is inside a imaginary surface. Now electric field, flux we have to calculate. See, if charge plus is here, so electric field line is coming like this from this top surface. But surface, how it is facing? Upside. The surface, upper surface is facing upside. So the surface vector is upside and the electric field is like this. The angle between is 90 degrees. Consider the down surface, the electric field is like this. Why? Because from positive charge, electric field state it goes. But the surface is looking down surface. So this is 90 degrees. Our formula for phi is equal to E ds cos theta. Here theta is equal to 90. So in this surface, from this surface, no flux is coming. X is equal to 0. Downward surface, no flux. Flux is equal to 0. So we left with 2 surface only. This surface is in this direction. See, this direction. So this is the E bar. This is ds bar. And this positive charge, this is the surface, back surface, and this is in this direction. And we know in electric positive charge, electric field lines will go in all directions. So here electric field also going in same direction. So as ds bar and E bar both are in same direction, angle is equal to 0. So maximum flux will be there, right? Maximum flux. What is the maximum? See, flux will come from this surface, flux will come from back surface. Only flux is coming from 2 surfaces only. So total flux linked with this one is equal to, see, Q by epsilon. Now don't confuse. Total flux. I discussed where the flux is actually coming. Upside no flux, downside no flux. This surface, yes, flux is there. This surface, flux is there. Total flux, this one, right? but this flux is coming from this surface and this is two surface only. See, previously from a cube, from all 6 surfaces, electric field lines are coming out. But here, upside, downside, no field lines, only here only. You may ask, sir, some 2 more faces are there. This surface, see, it is looking like this towards us, and electric field is like this. So that is also 90 degrees. Back side face also 90 degrees. So top, down, and sides, no flux, only this face, 2 faces. So total is whatever the charge enclosed in the surface and divided by the permittivity. But if each phase they ask, each phase of this, if a charge is placed at the center of the one of the place of the cube, what is the flux for each phase? If that they ask, see, we all know that flux comes from these 2 surfaces only. So one among 2 surfaces we have to select. So the flux of each phase, in this case, what is this case? Charge is at the center of the one surface of the cube. Previously, center of the cube. Then E surface Q by 2 epsilon naught. This is each. This another problem. Sometimes they will ask like this also. See, one cube we have consider, and at edge of this cube we have placed a charge. They will do like this. See, what is the flux? See, here also once again charge is outside. So we cannot apply Gauss law when charge is outside. So what to do? First, see, this is the base cube. Here at the top of this base cube, charge is there. So first you have to close this one. Right, now it is closed. Top, upside, one cube we have to place, totally one cube and totally one. So total 4 cubes you have to place upside, so that the charge will be at the center. I think you have understood. 4 cubes I have to place at the top. So bottom, this bottom, here charge is there, first cube. So I placed 2, 3, 4. That means 3 cubes I placed. At the top, to make the charge close inside, 4 cubes I have to place. This is my cube I have already taken. So total how many? 4 upside and 3 down. Total 7 cubes I am placing. Total 7 cubes I am placing. So 7 cubes I am placing, but my charge is on one of the cubes. So my cube plus 7 cube. So total how many cubes? 8 cubes. Totally 8 cubes. Right? So if totally 8 cubes are there, from each cube, how much flux is coming out? So from each flux from each cube. So each cube, how many cubes are there only? How many cubes are there we are having? Only total of 8 cubes are there. From each cube means we have to select 1 cube among 8. Right? I think you understood. Here also see, 2 surfaces are there. Each face means 1 among 2. Like that we have selected. Here total 8 cubes are there. Each cube asked, so from total 8 are there, 1 we have to select, 1 by 8. And charge per epsilon, 1 cube. Right? If 1 cube you have taken, this cube you taken, this is the basic cube you have, these other cubes we have imagined. But in the exam, in the problem, they have given only 1 cube, it is at the corner. So they may ask, from each surface of this cube, what is the flux? See, this is a little bit trickish. please concentrate. Very easy. Physics is very, very easy. Just we have to concentrate. See, here is our charge, right? So plus electric field direction is this one, right? Let us we name this one so that we can understand. A, B, C, D, E, F, G, H. Okay. Now this surface, which is A, B, D, C, top surface. This surface is looking upside. So ds bar is in this direction. So this surface, what is that surface? A, B, C, D surface is looking upside. That's why electric field and ds bar are different 90 degrees direction. So flux is equal to 0. And you take this surface, which one? A, E, H, D, this surface. Okay. This surface, if you take the positive, this one here, it is not there here, charge. Oh, don't confuse. Electric field direction is this one here, because electric field lines comes from positive charge, right? Here no charge is there, so from here only electric field will come. But this surface, the name is A D H E, right? So 90 degrees is there. This is downwards and this is upward, like this. Horizontal is downwards, so phi is equal to 0, right? So this surface, which one? ADFE surface, backside. That it is facing this direction. It is facing this direction. Which one? A, B, F, E. There also phi is equal to 0. Why? Because E is there, and that is backside, right? So for these three surfaces, see how many surfaces we are having for our cube? 6 surfaces. In that, 3 surfaces flux is equal to 0. So for remaining surfaces, this one and this one and whatever we are facing ourselves, in these 3 surfaces only flux will be there. That's why the formula becomes charge flux we are calculating from each cube. How much? Q by 8 epsilon naught. This is from each cube. In this cube, from each surface, how many surfaces are now having a flux? Only 3. So divided by 3. So how much we got? For each surface, Q is equal to 24 epsilon, right? This is how we have to apply the Gauss law in this various various cases. Now, if I take a charge here, I have enclosed in a circle, that is sphere. Why? Because in charge, all directions electric field will go. So around the charge, if I imagine a sphere, the sphere of radius r. So here electric field E bar is going on. So let us apply the Gauss law. The Gauss law, phi is equal to flux formula, surface integral E bar dot ds bar. This is the ordinary formula. Our Gauss formula is charge inside by epsilon naught. So total flux, let us take total electric field is E, and total surface is a small surface. See, here only we have taken this ds. This direction, this surface is looking in this direction. This surface is looking in this direction. That's why ds is also in there. Like that, so many surfaces we can imagine. So total surface. So 3-dimensional sphere, total sphere area we have to take, right? A small area, ds, total area. S is the symbol for area we are using. Total area formula for the sphere is 4 pi r square. R is the radius of the sphere, is equal to Q by epsilon naught. So electric field we can calculate. See what my intention is, by calculating the flux, we can as well calculate the electric field. That is my point I want to make. E is equal to, see, this 4 pi goes here. All constants I will write to one side. 4 pi epsilon naught. This is also a constant. And Q is the charge. This charge value may change and distance may also change. So this is the electric field around the charge. Is the electric field around the charge. From this Coulomb's law also we can have. See what is the Coulomb's law? Coulomb's law tells about the force. What is the force formula? If Q is the charge, E is the electric field acting on it, then force is equal to this much. So here Q is equal to here, and electric field we know 1 by 4 pi epsilon naught and Q by R square. If these charges are different, this may be Q1, this may be Q2, and you will get 1 by 4 pi epsilon naught Q1 Q2 by R square. Here it is your favorite Coulomb's law formula. If both four charges are equal in magnitude, so Q square by R square we'll write. Q square by R square. This is a Coulomb's law.